In our lesson today, we're going to be taking what we've learned about naming and writing ionic compounds and molecular compounds, and we're going to convert word equations to full balanced chemical equations. As we get started with this, we need to make sure that we remember the proper rules for writing each chemical substance as a formula. For ionic compounds, we're going to make sure that we continue to use our crossover method. We're going to watch for polyatomic ions, and we're going to watch for any elements that may have more than one charge. For molecular compounds, we use the prefix method, and those prefixes are provided for you on your periodic table to make sure that we write those formulas correctly. Now, one thing that's new in this note is introducing you to what's called diatomic molecules. These are elements that come in pairs, and we'll talk about that more in a second. Once we've written our chemical substances as formulas, we then balance the equation to show the proper ratios and quantities for both our reactants and our products. And we use the same rules that we talked about earlier in our balancing video. Diatomic molecules are new for us, and an acronym to help us remember them is this Hofbrinkel the clown. It recognizes hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine as being what we call diatomic gases. Many of these gases are said to be diatomic in that their elements on their own, they bond in pairs. They are so reactive on their own that they will always exist in pairs. These elements are indicated on your periodic tables. They are indicated in white writing on your periodic tables so you can recognize them quickly. For instance, oxygen gas is always written as O2. Nitrogen gas is always written as N2. And you can see here that would apply for bromine, but it would also apply for fluorine, iodine, nitrogen, and chlorine. So let's start with our first example to write, again, a full balanced chemical reaction from a word equation. Example number 1, we have calcium reacts with hydrogen monochloride to produce hydrogen gas and calcium chloride. So we're going to start writing out each element or each compound and their chemical formula. Well, calcium is by itself, so I can just write out Ca for calcium. When you see things like reacts with, that's just saying that we're adding these two elements together. So calcium plus hydrogen monochloride. We learned from molecular compounds that hydrogen monochloride, there is one hydrogen, and monochloride, we can write it as HCl. And we are producing, so I'm going to draw my arrow, we are producing hydrogen gas and calcium chloride. Now when I write hydrogen, I need to look at my periodic table and recognize that hydrogen is one of those diatomic gases that we were talking about. So hydrogen on its own will be a diatomic gas, and we will write it as H2. So we produce hydrogen gas and so plus calcium chloride. Now I can't forget my rules when I'm writing the chemical formula for calcium chloride. Calcium is a metal, and so I know this is an ionic compound. So again, I follow my rules for an ionic compound. One of the strategies I would use, I write my ions just kind of above the words. I know that calcium has a charge of 2 positive, and chlorine has a charge of 1 negative. Once I do that, I remember my rules, and in my mind, or you can do it in your notes, I'm going to imagine I crisscross those charges. So when I write that formula out, it would appear as CaCl2. So there's our chemical equation for what's happening here as opposed to writing out the words. The final thing that we need to do is balance. So if you like having left side and right side, we can write down the elements that we have and how many of each. On the left side, we have calcium, and we have 1 atom. We have hydrogen with 1 atom, and we have chlorine with 1 atom. On the right hand side, I'll write them in the same order. We also have calcium with 1 atom. We have hydrogen, which has 2 atoms, and I have chlorine, which has 2 atoms. And again, we need to balance this. So in order to balance my hydrogens, if I see that there's 2 on the right side or my product side, I'm going to add a coefficient here on the left side and indicate that I have 2 HCl's. make sure to double check. So now that my hydrogens are balanced, I can also look at my chlorines. By adding that coefficient of 2, we can see that we now have 2 Cls. And that balances what we have on the right-hand side. I have 2 Cls there as well. So I have 2 there, and again, that's balanced. My calciums were balanced to begin with. So this, as we've drawn right here, this is a full balanced chemical reaction. Let's take a look here at our second example. And if you want to give it a try for yourself, feel free to pause this video, attempt it yourself, and then press play and join us when you have your answer. For those of you who want to go through it right away, that's fine too. Iron here is mixed with oxygen gas to produce iron 3 oxide. Well, iron, we can write its chemical formula, Fe, is mixed. It's all by itself. Now, iron is a metal. It's not a diatomic gas, and so we can just write Fe all by itself. It's mixed with, and again, so we want to read through what's happening here. We're adding here oxygen gas. So I have oxygen. Now be careful here, and often one of the things that you can note in these word equations, anytime you see gas here, the last question was hydrogen gas, here it's oxygen gas, but make sure to note on your periodic table, oxygen gas is one of the diatomic gases we mentioned at the beginning of this note. So for oxygen gas, I'm going to write it as O2. Oxygen gas and iron are mixed together and they produce. So here's my arrow because I get something new. I get a new substance being formed. And that new substance is iron 3 oxide. Again, if you want to write the charges above here, the Roman numeral 3 is indicating we have iron 3 positive as opposed to iron 2 positive. And we know oxide is 2 negative. So again, if you want in your mind or on your question sheet, you can just go ahead and crisscross those charges. So when we write it out, we still follow the proper rules for ionic compounds. I have Fe2O3. So there's our chemical equation. The final thing we need to do is balance it. So we can look at it. You can do a left side, right side, but you can see right here, I'm going to start with our oxygens. Our oxygens don't match. If I have 2 on my left-hand side as my reactants, and I have 3 on my right-hand side, I want to come up with a number that is common to both of them. In this case, 6. So when I want to make oxygen 6 on the left-hand side, I'm going to add a coefficient of 3. That gives me 6 oxygens on my left-hand side, my reactants, and I'll need to add a 2 for my product side so that I have 2 times 3, I have 6 oxygens. Now, after we balance the oxygens, we need to consider our iron. 2 times 2, I have now 4 Fe's as my products. So I need to balance that up on my reactant side, and so I'll add a coefficient here of 4. There is a balanced chemical reaction. We know the ratios, and we know how the chemicals are arranged. Let's take a look at example 3. And again, feel free to pause the video if you want to try this one on yourself before checking your answer over. So for example number 3, we're going to look at hydrogen monochloride reacting with calcium hydroxide to produce calcium chloride and dihydrogen monoxide. Well, hydrogen monochloride, when we look at this, I see this prefix mono, and so I know it's a molecular compound. And so when I'm writing the chemical formula for hydrogen monochloride, I'm just going to follow those rules. It's hydrogen, and it's monochloride, and so it's just 1 Cl. And it reacts with, so I can put a plus sign here, calcium hydroxide. Now calcium hydroxide, calcium is a metal, okay? Hydroxide, I recognize that as a polyatomic. And so I need to follow my rules and I need to consider what the charges are. Well, calcium, if you find it on your periodic table, has a charge of 2 positive. Hydroxide, when you turn over your periodic table, you'll be able to look it up, and it has a charge of -1. So when I crisscross those charges, I'm going to get calcium OH2. That's what I see a lot of people do. And we got to be careful of our rules. We actually have 2 hydroxides when we crisscross this. So make sure to review your ionic compounds if you don't remember this. But we need to put brackets around that anytime we have more than one polyatomic. So I have calcium, OH, and I have 2 of those. So I need to indicate that with brackets. This is producing calcium chloride. Now it's written on separate lines, so hopefully that doesn't throw you off. But calcium, again, we know is 2 positive, and chloride has a charge of 1 negative. So when I crisscross those, I have calcium Cl2. And then we have dihydrogen monoxide. This is a molecular compound, and you might recognize this right now. Dihydrogen, 2 H's, monoxide, 1 O. That's the chemical formula for water. So there's our chemical formula. Hopefully you get that to that point. The final thing we need to do is we need to look at balancing it. Now for this balancing, I'm going to write out here my chart here, left side and right side. Because one thing that you'll notice is that this polyatomic, I have OH here and I have H's here. So I have to consider, because I only have H's in one spot on my products, I have to consider all the H's I have on the left side and all the H's I have on the right side before it's fully balanced. So when I write this out, I have this H. Right now, I have a total of 3 H's on the left-hand side. I have 1 chlorine, I have 1 calcium, and I have 2 oxygens. Don't forget that this 2 multiplies everything that was in that bracket. On the right-hand side, I have, we'll just write this in order, I have 1 calcium, I have 2 chlorines, I have 2 hydrogens, and I have 1 oxygen. Now again, you can kind of move things around as you see fit, but I'm going to start off and I'm going to try to balance my chlorines because that seems fairly straightforward. If I have 2 chlorines here on my product side, I need to have 2 chlorines over here on my reactant side. So I'm going to go ahead and add a coefficient of 2. When I do that, I now have 2 chlorines, so that's balanced. I now have 2 hydrogens here plus 2 hydrogens here. So I've changed my hydrogens and I now have a total of 4 hydrogens. So if I try to balance that now, I can look at the right hand side and I need to have 4 hydrogens, and so I'm going to add a 2 here as well. My hydrogens right now, I have 4, so my hydrogens are balanced. I already balanced my chlorines. And you can see here now, this 2, I've now got 2 oxygens. So when I write that in, 2 oxygens, I see that I've actually balanced my oxygens. And calciums were balanced to begin with. One of the things you'll notice, if you're having trouble balancing, you've probably written your equation wrong. When the equation is written properly, the balancing should come together fairly straightforward. Let's get into our last example as we finish up this lesson. We have dicarbon hexahydride reacting with oxygen to produce carbon dioxide and dihydrogen monoxide. Remember, when we see these prefixes, we know that we're dealing with molecular compounds, and so you can use that prefix chart on the back of your periodic table to help you. Dicarbon represents 2 carbons. Hexahydride represents 6 hydrogens. So I have C2H6 is reacting with oxygen. Now be careful, it's not written here. In the other ones, we'd often say oxygen gas. It's not written here, but oxygen, when you look at your periodic table, it shows up in white on our periodic table, and that indicates that it is a diatomic molecule. So I have C2H6 plus oxygen is producing carbon dioxide, which is probably pretty familiar to you, CO2. And again, we have this dihydrogen monoxide, we have water. So there's our reaction. That's not too hard to come up with, but the balancing here is a little bit trickier, and this would be probably one of the trickiest ones that we do. So we can again do a left side, right side, or if you're comfortable, we can just kind of start one at a time. If I have 2 carbons over here, I need to make sure I have 2 carbons in my product side on my right side. So I'm going to add a 2. Now, when we continue on and we add up our hydrogens, we have 6 hydrogens on our left side, our reactant side, and I only have 2 over here. So I need to balance that out as well. Well, if I try to balance that out, I would get 6, I need to multiply by 3. And so I add my coefficient there. So my carbons and hydrogens are all balanced, but let's take a look at the oxygens. I have 2 oxygens on my left-hand side. On the right-hand side, my product side, I have 2 times 2, I have 4 oxygens here, and I have to consider all the oxygens on this side. So I have 4 oxygens here, and I have 3 oxygens over here. I have a total of 7 oxygens. Well, to get to 7 oxygens, I would have to multiply this oxygen by 3.5. 3.5 times 2 would give me my 7. Now, chemists don't like putting anything other than whole numbers as their coefficients. So anytime you get a decimal or a half, we need to multiply the whole thing by 2. And so I'm going to rewrite this again. If we multiply everything by 2, well, I'll write out the equation here first. C2H6 plus O2 so here's our equation. And what I mean by multiplying by 2, we can't have 3.5. We need to multiply everything by 2, so that's a whole number, 7. Well, if we multiply everything by 2, again, we're looking at those ratios. I'm going to have 2 C2H6. I'm going to have 4 CO2s, and I'm going to have 6 H2Os. There is our full balanced chemical equation for us to look at. I hope that helps. Remember with these word equations, look for ionic compounds and use the appropriate rules. Look for molecular compounds and use the appropriate rules and the prefixes that we provided for you. The new thing to remember from today is that there are diatomic molecules, and those diatomic molecules are indicated in white elements in your periodic table. They exist in pairs, so only when they are by themselves are they diatomic. If they react with other things, we just use the normal rules. I hope that helps. Good luck on the worksheet.